Hey everyone! In this video, we're building a cool typing effect in Java Swing, glowing text particles that animate and fade away as you type. Let's break down the core logic, starting with the typing panel class. First, let's add a new JFrame to our project. Name it typing frame. Once it's created, resize the JFrame to the dimensions you want for your typing effect window. In the Properties panel, set its title to typing frame so it shows up in the title bar when we run the program. Now, from the Swing palette, drag and drop a JPanel into the JFrame. Resize the panel so it fills the entire frame. Finally, in the inspector, rename this panel to Drawing Panel. This will be the placeholder area where we'll insert our custom typing panel animation later. Now we define a class called Typing Panel, which extends JPanel and listens for keyboard input and animation events. First, we import all the necessary packages, from Swing and AWT for UI and graphics, to utility classes for managing animation. Our typing panel class extends JPanel, which means it's a custom panel we can draw on and add to a Swing window. By implementing KeyListener, this panel can detect and respond to keyboard events. It also implements Action Listener, which lets it respond to timer events. Inside, we have a small inner class called Particle. Each time we type a key, a new particle is created, storing the character, its position, transparency, and how long it should live on screen. Inside our particle class, we start with a constructor that takes three parameters: the letter to display, and the x and y coordinates for its starting position. We store these values so each particle knows what character it's showing and where it should be drawn on the screen. The update method makes the letter move upward and slowly fade out. When the particle's alpha reaches 0, it disappears. IsDead method checks if the particle's life has run out or if its transparency, represented by alpha, has faded to 0. If either condition is true, the method returns true, meaning the particle should be removed from the animation. Then, we set up our typing panel. We're keeping track of all particles with an array list, and using a swing timer to update the animation around 30 times per second. Now, let's take a closer look at our typing panel constructor. This is where the panel's initial setup happens. First, we set the background color to black using setBackground method. This creates the perfect contrast for our glowing text effect, making each letter pop out visually. Next, we call setFocusable method. This ensures our panel can actually receive keyboard input. Without this, the KeyListener wouldn't work. Then, we attach our KeyListener with addKeyListener method. After that, we create a new swing timer with a delay of 30 milliseconds, passing in this as the action listener. This timer will run about 33 times per second, constantly updating and repainting the animation. Finally, we call timerStart method to kick off the animation loop immediately. Now let's break down the heart of our drawing logic, the paintComponent method. First, we override paintComponent method to customize how this panel is painted. The very first line, super.paintComponent method, clears the background each frame so old drawings don't overlap. This is crucial for smooth animation. We then cast our graphics object to Graphics 2D, giving us more powerful drawing features like alpha transparency and better text rendering. Next, we loop through every particle in our particles list. For each one, we set its transparency level with setComposite method. We set the drawing color to cyan, that's our glowing text color, and choose a monospaced, bold font size 20 for consistency and spacing. Then, using drawString, we render the particle's letter at its current X and Y position. Since these positions update in real time, the letters animate naturally on screen. Finally, after the loop, we reset the composite to full opacity. This ensures that any future drawing isn't affected by the particle's fade-out settings. This method is called automatically whenever the panel is repainted, which in our case happens about 33 times a second thanks to the swing timer, creating a smooth, glowing typing effect. Now let's add the override methods from our KeyListener and ActionListener interfaces. From KeyListener, we'll implement three methods: keyTyped, keyPressed, and keyReleased. From ActionListener, we'll override the actionPerformed method. This is where the magic starts. Whenever you press a key, the very first line takes the character you just typed, turns it into a string, and creates a new particle at the current cursor position. That particle will then be animated and faded out by our timer. After adding the particle, we move the cursor horizontally by 20 pixels. This spaces out each new letter so they don't overlap. Then we check if the cursor has reached the right edge of the panel. If it has, we reset the horizontal position back to 50 and move the vertical position down by 30 pixels, just like moving to the next line in a text editor. In short, this method takes every key press, spawns a glowing letter on screen, and makes sure our typing effect flows naturally across and down the panel. And finally, the other two KeyListener methods are required, but we don't use them here. Now, let's break down the actionPerformed method. This is the engine that keeps our animation alive. First, we grab an iterator for our particles list. This lets us safely loop through each particle while removing any that are no longer needed. Inside the loop, we call update method on every particle. This moves it slightly upward and reduces its transparency, making it fade out frame by frame. Then we check isDead method. If the particle has faded completely or its life counter has reached 0, we remove it from the list so it's no longer drawn. This keeps the animation smooth and efficient. Finally, we call repaint method, which triggers the paintComponent method to draw the latest state of our particles. Import Java border layout class from AWT package. Now, let's walk through the constructor of our typing frame class. Next, we create a new instance of our custom typing panel. This is the panel that handles all the glowing typing effect logic. We set the panel's size to match the drawing panel container, ensuring it fills the space we designed in the GUI builder. We set the layout of drawing panel to border layout. This allows the typing panel to expand and fit perfectly inside it. We add the typing panel to the drawing panel, replacing the default placeholder panel from the GUI builder. Finally, we call requestFocus in window method on our typing panel. This makes sure it's ready to capture keyboard input as soon as the frame is visible. Thanks for watching. This real-time glowing typing effect was built entirely with Java Swing, no libraries, just pure code and creativity. Every character you see is animated live, right as it appears. If you liked this, drop a like, share it with a fellow coder, and don't forget to subscribe. More effects, more Java magic, coming up soon.